Hello and welcome to the computer learning class by Accelerate Computer Systems. My name is Arun and I will be your trainer today. Sometimes you will be given an IP address and subnet mask and you will need to find out the network address. For example, if you are in office working as network administrator and you want to find out the network number for HR so that you can add another user to that network by finding out how many computers you can add. You can take the IP address and subnet mask of one person from HR and based on that, calculate the network address to find out how many computers can be added to that network and what is the start of the network and what is the end of the network. Today we are going to learn the same. Let's start with our lesson for today. You are new to a company and managing the networks there. You come across a network issue in a computer with the IP address 192.168.1.56 and the subnet mask of 255.255.255.192. You want to check quickly if other people in this network are facing the same issue. How would you find out the network with just IPv4 address and the subnet mask? Let's start with the very basic. We know that an IP address includes IP address and network portion. So this part itself, it contains both the IP address and the network portion. And the subnet mask just helps the computer identify which portion is network and which portion is host. The first step is to convert IP address and subnet mask into binary. For this lesson, we assume that you already know how to convert numbers from dotted decimal to binary and vice versa. If you do not know, then I recommend that you watch the video on this topic. There we go. Now the second step is to compare binary values for IPv4 address and the subnet mask. Let's do that now. All right, now let us clean up the slide and move the binary to have a look at the IPv4 address and subnet mask. Let us first find out how many addresses are there in this network. To find that out, we need to simply put the place values in the octet, which is the last ones going from left to right. In this case, it is this last one. Now we need to find out the place value for the last one from left to right. That the last one is at 64. Now this is the number of IP addresses this particular network has. Now we need to find out the network address in which this IP address falls. To do that, we need to compare binary versions of the IPv4 IP address and the subnet mask, both of these. Here is how the comparison result is obtained. Keep in mind that we will compare these two bit by bit. While comparing, if any of these bits is 0, any of these is, then the result is going to be 0. Only if both the bits are one here in IPv4 address and the subnet mask, they are 1, both of them, then the result will be 1. This way, now we get the result as all right, let's have a look at it. So if you see here, both of these, they are 1. So the result is 1. In this, they both are 1s. The result is 1. Rest here, it's 1, but here it's 0. So it's going to be the same. Same way here. All right. The last one is all zeros. Why is that? Because if you see here 1 and 1, but here it's 0 and 0. And the rest triple 1, but here it's 0. So everything is going to be 0. Okay. Now we need to convert this binary number into dotted decimal. So this particular number, we need to convert into decimal, dotted decimal. We get the result as 192.168.1.0. This is the network address for this particular network. Remember that in any network, the first IP address is reserved as network address and the last IP address is reserved as the broadcast address. Now we are talking about IPv4. All right. This is the network address. We know that this network has 64 IP addresses. This way, the last IP address or broadcast address will be 192.168.1.63. Now, why the 63? Remember, from 1 If you count starting from 1, then it's 64. But here in this case, we are starting from 0. That's why it is 63. Okay. Now these two IP addresses are reserved. This one is for the network address, and this one is for the broadcast. This means that we can assign the IP address range from 192.168.1.1, which is one more than this, and 192.168.1.62, which is one less than 63. These can be, IP addresses. They can be assigned to end hosts or computers. All right, so here are the steps to find out the network of any given IP address based on the IP address and subnet mask provided. The first step is to convert IP address into binary. Once in binary, we need to find out, going from left to right, the last one and its place value. This place value shows the number of total IPs that are there in this network. Now we need to compare binary values for the IP address and subnet mask and write down the result. Keep in mind that we need to compare both binaries bit by bit, and only if you find a 1 in both, the result will be a 1, else the result will be a 0. This is also called ANDing. Once you have compared both binaries and have the result, then convert the resulting binary into dotted decimal to get the network address. If you want to find out the broadcast, add the maximum number of IP addresses available in the subnetwork to the network address. In our example, the total number of IP addresses available were 64. So we will count 64 starting from 0 and get 63. This will be the broadcast address. Now we know that any IP between the network address and broadcast address can be assigned to the end hosts and or computers. At Accelerate, we work with students and startup companies in Canada by providing them with high performance and low cost computing devices to help them learn and grow. These Dell laptops, they start at just $400. If you would like to know how you can save on your next laptop purchase, do send us an email on the email which is flashing on the screen. Thank you so much for learning with me today, and I will see you in the next video with a new topic. Until then, happy learning.